I never met Rob in person, but last year he was supposed to be our presenter and it did not happen. So this year Rob is online, and I know that he has many years of experience in IT industry, and now he heads up the engineering and architecture functions in Angle Finance. That's Australian company. And Rob will talk about credit policy using text-based rules. Okay, Rob, take over.
Thanks. Thank you very much, Jacob. Thank you very much, Sandy. And yes, good afternoon, good evening, and good morning to everybody, depending on where you are in the world today and what time zone you're in. It's been a long day, and this is the last presentation before drinks are going home. So I might try and speed things up a little bit and try and get through it a little bit more quickly. Whoops. Hang on. Just got to get control of the presentation back. Here we go. So the question is, what's the problem? What's the problem we're trying to solve? And what are we about today? So we have an existing credit policy, and it's a traditional credit policy written in traditional text language, and it's currently implemented in a system using traditional 3GL language. But what is really the drivers for change here? And it's three things. It's about speed, it's about strategic attractiveness, and it's about scale. So what do I mean by speed? Well, it's about keeping pace with digital agility and having more, or digital business, and having more agility and responsiveness in our ability to change our credit rules and update them, etc. It's about decreasing time to yes and time to cash. It's about shortening the time to deliver new initiatives. And it's just about the time to affect BAU change. And what do I mean about attractiveness? Well, it's about modernizing our technology stack in order that we can attract talent. It's about attracting further investment in the organization and the company. And it's also about making our products attractive in the marketplace. So to remain competitive, we need to keep tuning our credit policies and our credit decisions to keep pace with our competition. And lastly, it's about scale. It's about our ability to absorb new business and increase our revenues without increasing costs at the same rate. So what's our solution? It's about automation. It's about process automation. It's about decision automation, and it's about modernizing our technology stack. So my name's Rob Parker. I'm from Angle Asset Finance, and I'm here to talk to you about our experience as we've started our decision and indeed process automation journey. So who are we and who is Angle Finance? Well, we do asset finance, which is basically a means for organizations to get a source of funding for funding capital intensive equipment or plant such that they can also increase their revenues and growth. We're a young company, but we're growing quite fast. And this is why those business drivers are pertinent, because as we grow, we need to scale out our business. And as we scale out our business, we also need to make our products attractive to keep fostering that growth. And so where are we? Well, we're in the land down under. We've got offices on the east coast of Australia. And I can assure you that right now it is just after 7 a.m. on Tuesday morning. And if my voice is a little croaky, it's because it's been a little bit of a long night for me. So before I get into some of the more details about our decisions, etc., I just need to give a little bit of context about asset finance, and in particular, some of the sources of the complexities within our decisions. So what's the business context? Well, it starts off with an organization or a customer of ours is requiring additional plant and equipment in order that they can either increase their sales, become more efficient, expand into new markets, etc. So what's asset finance? It's effectively the business customer applies for some sort of credit facility. That could be a secured loan, a finance lease, or even rental. And after approval, we might provide the means of funding or the capital in order that they can actually procure that piece of equipment. So now it's the information context which becomes quite interesting, because quite often I'm finding that our data structures are more akin to graph data structures. So for example, we might have an application which might have a single applicant as the borrower. But likewise, we can have applications where there might be multiple borrowers. So I can end up with many borrowers. And in addition to that, the type of applicant or the borrower can be various different types. So for example, we might, and predominantly we deal with organizations or organizational structures, but associated with those, we have individuals. So we've got multiple borrowers of multiple types. And then within that structure, we've got multiple classes of organizational structure. For example, we might have trusts, sole traders, organizations, etc. And within that, we can have complexities such as, for example, we might have a trust, and the trustee of the trust is actually a company. And therefore, whenever we've got an organization, we also need to collect an individual who might act on behalf of that organization. So within the customer space, we can get some quite complex graph or tree-like structures in terms of the applicants. And likewise, when these customers are applying for credit for an asset, we might have some simple deals where it's a single asset, for example, a truck, and that's quite a simple case. But then we can have compound assets. For example, an organization might be applying for a B-double or a prime mover, which comprises two assets, which is one, the prime mover, and then secondary, the trailer or the accessories associated with that. And then we can get even more prolific cases where, for example, the business might be applying for a fleet of vehicles. So rather than having a single asset, we actually might have a collection of assets. And sometimes that collection might be a homogeneous set of assets, as in a fleet of trucks. And sometimes it's a heterogeneous mix, which could be a mix of office equipment plus office consumables, etc. And so that brings us to the decision context. So what are the decisions we're talking about? And basically it boils down to qualification. So typically we are qualifying the applicants as worthy for the line of credit. We are qualifying the assets as in that is an asset class or an asset risk profile which we are prepared to lend against. And then it's qualifying the arrangement, which is, yes, that particular business construct in that particular industry does meet our credit rules for that particular type of asset with that particular type of characteristics. So that's a bit of the business background, which hopefully will make sense as we start to get into the decision rules. So the next thing we started with, and the very first engineering decision is, well, what are the actual business decisions? And in reading literature, you often see guiding principles such as start with the high-level decisions and then uncover the business rules. So in our case, we actually went contrary to this because we started with the credit policy, which actually has the detailed credit rules. But the problem with the credit policy is it's written for human consumption. It's not written for automation or machine consumption. And so the way it's structured is not amenable to a one-for-one mapping for just pulling out the credit rules and identifying the high-level decisions. So what we did is we did a first pass through the credit rules, but then we started to consider our effectively corporate information model, or what are the business entities the business deal with? And the classic entities are, we have applicants, we have obligors, we have guarantors, we have assets and asset types. We have the product configuration, which is details such as how much does the person want to borrow, what's the term, what is the repayment frequency, etc. So then what we did is, as we went through the credit rules within the credit policy, we started to tag each one with the relevant business construct or business entity associated with that credit rule. And then what we did is we started to coalesce all of those detailed low-level rules into clusters associated with the actual business entity. And what we found is the actual high-level business decisions started to emerge. And so we ended up with, for example, these three decision or high-level business decisions, which is, one, there are detailed rules which are really about qualifying the product configuration. And what I mean by that is it's an acceptable term, the amount is within tolerance, etc. And then we have rules which are about qualifying the applicants. For example, the applicant has been in business long enough, the applicant has a suitable credit score, etc. And then we have some rules which we classified as qualifying the arrangement. And that is, those rules are a combination of the product configuration and the asset type and the applicant. For example, we might have rules which say an applicant with this particular credit worthiness or longevity can borrow up to this amount or this much, provided it's for an asset class of this particular asset type. So that's decision number one, is what are the actual business decisions. So the next engineering decision we have to make is fundamental, and it's what is our actual architecture. Now, at this point in time, we've actually already made one kind of implementation or technology decision, and that is we have chosen to adopt DMN. And our rationale for that is to leverage the promise of DMN in terms of standards compliance, consistency of execution, transparency of execution, commoditization of the platform. So we've already made the decision of DMN, but the question now is, how do we realize that, and what is the architecture? So some classic examples, we could start with decision as a service. And there are numerous platforms out there now which offer this, which is basically a platform, typically cloud-based, where a business can model their decisions, deploy the decisions into this platform, and these decision as a service platforms will expose those decisions typically as an API. So that's the value prop there. An alternate architecture is what I call the inline or the process model. And so what we see is a number of process automation platforms, for example, a BPMN automation platform. And quite often they might have a decision engine co-located within that platform. And this is really good for when the business process has a decision task which needs access to a decision. But sometimes these platforms, it's more difficult for a client to actually call the decision directly, particularly when the client wants to call that particular decision outside of a business process. And the last architectural style is what I'll call the embedded, which is basically you might take a DMN engine library and embed it in your own application. So one of our guiding principles is we wanted to start small, we wanted to keep it simple, and we wanted to start with low cost, because this is a bit of a learning curve for us and a bit of an experiment. So what we did is we've actually got a hybrid implementation. So we started with the embedded model. We took a DMN engine as a library and embedded it in an application. And that application effectively becomes a decision server. So it starts to serve up decisions. So what we then do is we deploy that using cloud technology. And using cloud technology, we start to get the characteristics of the DaaS platform. And in particular, we also run this application in cloud technology behind a cloud API gateway. And so we start to get decisions exposed as APIs in a cloud-based platform, which gives us a lot of the characteristics of DAS. And another benefit of this is if we want to run those decisions in line with the process model, we can take a process engine or a process platform, and effectively for the business rule tasks, we can implement that using the characteristics of a service task such that the process is effectively calling a decision service. And so with that, we start small, we start cheap, we get the benefits of all of these combined, and we also get the opportunity to re-platform as we grow. So that's our architectural decisions. So now we start to get into some of the more detailed business decisions, and in particular, how do we implement some of these constructs in DMN and feel? So an example here is when I've got one of these graph structures, how do we implement our decisions in terms of iterating over these structures? Do we use the process layer or the client to manage the iteration over the structure? Or do we embed the iteration in the decision implementation itself? So as an example, we typically see business rules such as all applicants must be over 18 years. So option one is, again, I might have a client which is collecting the information or collecting the application. And so on the client side, we've got a configuration where I might have collected multiple applicants. And so what it can do is it might call a fairly simple decision service, which is pass across an applicant, and that decision just comes back with true or false that the applicant is over 18 years. The alternate model is iterate at the decision layer, which is effectively within the field or within the decision table. We might use the capabilities of the field language, and in particular its list structures, such that we can have a single field expression such as every applicant in applicants satisfies their age over 18, etc. So this is one of the decisions we had to make. And so basically the answer is, which way should we go? It depends. It actually depends on the context. It depends on your implementation. It depends on the rules. So we've started to come up with a couple of guiding principles. And effectively, our first guiding principle is we try and implement the rules based on first principles as much as possible. So we actually discourage having a field expression, which is something like turn the decision column into, rather than a numeric, it's actually a Boolean. And the Boolean is the applicant over 18? And we use a field expression for actually parsing the input and turning that from a numeric expression into a Boolean. So what we prefer is first principles, which is, yes, just pass in a numeric expression, and within your field, within your decision table, use a column based on that, and within the table's cell expression, actually have the equivalent of a greater than or equal to 18. The next guiding principle we had is, if there is only one attribute or one criteria, then yes, using the list expression to kind of aggregate into a higher level construct, we'll kind of tolerate that for implementation efficiency purposes. Our next guiding principle is, if there are multiple criteria, then try and keep the decision table simple and iterate over the client. However, as we'll soon see, these are some guiding principles, but we have some more depending on how much more complicated it gets. So sometimes another consideration is cost versus elegance. So consider a use case where we've got a business rule, which is, for example, all applicants must have a credit score greater than some threshold. So the challenge here is fetching a credit report, and in particular, credit reports cost. So what are our choices here? Well, one is what I call the pay up front model, which is effectively go and fetch all of the credit reports and you'll pay for everyone, and then effectively get the client side to iterate over each credit report one at a time. The alternate model is what I'll call pay as you go. So what I mean by that is the client side can iterate and effectively go and fetch the report and then call the decision one at a time to approve or qualify the applicants one at a time based on their credit report. So the trade-off here is by calling them one at a time, or the pay as you go, you might actually have an economic saving because you might fail the deal sooner without incurring the cost of actually retrieving the credit report for all of the applicants. The guiding principle effectively we use here is we say, well, keep it simple. So perhaps go with the pay up front by fetching all the credit reports and then calling the decision engine for this decision once at a time. Our next guiding principle is don't optimize prematurely. So that's why we start with simplicity, because we might find that in the majority of cases, we're actually very rarely failing the customers based on a credit report. And so therefore you actually very rarely actually save any value by fail fast up front. And the next guiding principle is effectively use your data analytics at runtime after you've deployed the decision for a while to actually tune and optimize the decision. So next decision is an example about ordering. So sometimes we have some use cases where we have business rules which are based on aggregating classifications from master data into more coarse-grained classifications determined by the business. So for example, we have a government business registry where you can interrogate the registry, and given a business identifier, it can come back with lots of codes as to the structure of the business, whether it's public or private, whether it's a sole trader, a trust, etc. And quite often we have business rules which don't want to go down to that level of granularity. They actually want to operate at a much higher level of abstraction. So for example, we might have many types of public company, or we might have many types of codes which represent government. But effectively, we start to build some decision mapping tables or some capability to abstract those lower level codes up into these higher level abstractions. And so to a developer who's more familiar with using feel or using code, it's quite attractive to them to start writing some of these rules using feel code similar to this. But what's the problem? So at face value, this looks quite effective and looks like it will work. And in testing, if there is only one obligor, then this will always work. So the order doesn't become important. But think about what happens if this decision or the outcome of this processing feeds into another decision, such as, for example, we might have a rule that if the prevailing type within the obligors is of type government, then their lending threshold might be higher than, for example, if the prevalent obligor type is public. And so what can happen in this circumstance is order becomes important, and this becomes quite dangerous and quite brittle, that if we were to put this out there in production, whilst it works in the single use case, as soon as we start to get the multi-instance use cases, then this breaks. So of course, the guiding principle here is we would prefer to use unique hit policies over, this is the equivalent of a first hit policy with a default. But sometimes actually coming up with the unique hit policies can be quite complicated. So another issue we have is sometimes generating the unique and exhaustive state space may be difficult in complex cases. So our other guiding principle here is if we are using expressions using these list functions, for example, something like the sum, then we must pay particular attention and diligence to make sure that we don't run into these situations where it can be brittle in terms of order or further dependencies on other decisions. And so you might have started to see a bit of a pattern emerge. And one of the observations we've made is when we show DMN to a business user, we're finding that whilst the table construct is quite familiar, particularly to those users who use an Excel spreadsheet, the concept of feel as a language tends to be seen as yet another language and something not necessarily readily embraced. Whereas to the developer, feel as a language is a familiar paradigm, and developers are quite used to adopting new languages. However, the table construct seems a little bit foreign to a back-end developer. So you might have noticed a pattern emerging, which is we were tending to use quite a lot of feel expressions, either as first-class expression implementations. We might be using feel in a lot of cases as input transformations, for example, transforming the is age over 18 into all applicants are over 18 into a Boolean. And another example of where we started to use feel is quite often we were decomposing the business decisions into sub-decisions, and effectively at the top level decision, there's a requirement to aggregate
Okay, we're having a minor bandwidth glitch. Let's just give it a second and see if Rob gets back. Okay, we lost our presenter. I assume that he's going to try to get back in. Let's just give him a minute and see if he's able to make it back in. I'm finding this a very interesting presentation with a tie-in with some of the earlier presentations. The idea that feel is just considered, just another language by non-developers as opposed to a part of a low-code environment, and just this sort of trade-off between